Hello everyone, hello my friend on the social media. Today I gonna design and construction of the IoT system to read data from the environment and then control lot via app to support the agricultural industry. And the first step I gonna move to directly to the real system, and then I gonna show how to build and design the code and the hardware for this system. Don't forget to like, share, and subscribe my YouTube channel. The system include the laptop and the humidity and temperature sensor. The smartphone already installed the IoTVision App through the CX Play and the App Store, and the PCB port, and we use the lens to simulate the actuator. After successfully checking the system in the mode, we rotate to check the system in manual mode when lost in the K1 and K3 is turned on. The light of the K1 temperature simulate the system, and the K2 humidity will be activated. At this time, the loss indicator like K1 and K2 on the app will be light up to notify the user that the loss had been activated, vice versa. You can see and after the system has been connected to Wi-Fi for the system in the app interface. Here is the code interface, the Arduino IDE app, and we're gonna switch to the auto mode, and the ambient temperature and humidity increase to greater than 30 and the humidity is greater than 80 to activate the K1 plot and turn off the K2 plot. The research we guess is the correct sequence, and the K1 light will be turned on to simulate the temperature lot, and the K2 light will be turned off to simulate the humidity lot. Here you can see the research. Hello everyone, hello classmate, my teacher, friend via social network. Today I gonna design and construction of the IoT system to read data from the environment and then control loss via app to support the agricultural industry. And we're gonna start with what is the IoT. Yeah. Internet of Things is a network of device, sensor, machine, and the system connect together via the internet, and the device can collect, exchange, and process the data without direct human intervention, create a smart economic system. And structure of IoT include the reception layer, X device, the transport layer, gateway, the processing layer, and application layer. And here, so mandatory requirement of an IoT system is comparability. The system needs to support a wide variety of device and sensor, ensuring the compatibility and easy connectivity. And high security ensure the data security over the network and on device using methods such as encryption, and management, and to control the engine to organize and manage data efficiently, including the storing, the processing in the cloud when needed, and the user interaction provide a friendly and easy to use user interface to interact with the data from IoT device. And the program software and the control application we use in the Arduino IDE for this is the programming software, and the Arduino IDE is short software primarily used for writing and compiling. And the Arduino IDE consists of different parts, include the window bar, menu bar, and the shortcut key, text editor, and the output panel. And, yeah, we're gonna move. Move to how to install the app and register via phone. In this system, we use the app IoTVision made by Thái Nguyễn. This is a doctor from the Ho Chi Minh City University of Technology and Education. And the step one, we go to the App Store and select Play to search by the keyword. And step two, to check the app information as below and select the install. And step 3, to create an account on the app, the admin account will be given direct by the teacher. Configure the information in the app here. And we're gonna move to the important step. This is the programming using API. What is the API? API is an application programming interface, a set of rules, protocol, and a tool that allow the different application or system to communicate and interact with each other. API action at a bridge, so that one software can request the data or service from another software without having to understand the detail of how to the other software work. And the API filter include the system connectivity. API have different application system and other device to communicate easily and efficiently. High complexity API provide a layer of abstraction, hiding complex logic inside a system or service, and easy to extend and review. How to API work? API, when API or the system want to communicate with other systems through an API, it send a request via the API. It send a request and API return a response. Both the request and response follow a specific format, usually JSON and XML. And in this system, we use the JSON to communicate with each other. And the API testing process is step 1. Determine the API URL. In this part, the API address provided by my teacher. This link below. And this step 2. Configure the postman to send the data. Here in encrypt JSON, and here you can see the 10007, and one is the case 1 is the loss. In this system, we use to replay K1 and K2, and 7 7 and 7 is the signal level of the device, and 23.5 and 82.9 are the measure by temperature and humidity. And the time is the real time when the data were collected. And step 4, we want to check on the IoT app, verify the JSON string information were sent successfully by checking the information on the IoTVision app to matching the information is length is step 3. In the chapter 3, the system design to meet the needs of monitoring and control system serving agriculture crop. The first necessary to present a block diagram describing the system and the operating principle of each block. We designed the system to the two modes, include the manual and auto mode. In the auto mode, when the temperature our brain the relay 1 on, and the humidity our brain relay 2 on. In the manual mode, we can turn on or off the relay 1 and 2 when it is. And the design methods. With the above requirement, we design the system into the following hardware: power block and central processing unit, control and monitoring block, data collection block, and executive block. Here is design diagram block of the system. A power block to provide the power for entry system, including the power conversion, 220 VAC, 5 VDC, and 3.3 VDC. Data collection block use temperature and humidity sensor to obtain the information from the environment. A real-time module block to provide a real-time to the center processing block when display the time through the monitoring block and display the backup battery when the main power is lost. Status indicator block indicator power status of actuator status. The system use a single LED status indicator. The actuator block to execute the system outputs in the auto and manual mode. Monitoring and display block. The system monitor and display the via IoTVision app. We're gonna move to the design is block, the hardware, the power block. And the real-time module block, the actuator block, executive block, and the central processing unit. We define clearly the pin of the ASP32. This is the chip usually used in the manufacture. To GPIO below is the receive signal from the switch, and the GPIO 30 and 21 to set as the output of control relay. The GPIO 90 and 80 to communicate with the XXT 31 is a sensor temperature and humidity. This is the interface monitoring and display block. We move to the chapter 4, the system constructor overview. After performing the design step, we will present the step of complete the hardware assemblies, board testing along with simulation. Present the follow chart, describe the system to have a detailed view of how the system works. This is the PCB layout. PCB design method and function. separate of the signal Y and AC power Y, optimize signal Y design, reasonable VR layout, PCB area isolation, AC and DC series partition, avoid the signal Y intersection, routing the corner of the series. We need to focus to the power and GND Y side is the largest than signal Y. The power curve is a positive 5 voltage and positive 3.3 voltage, and GND design wider than the signal curve, especially from 0.5 to 0.7 millimeters. This is a system construction. We're gonna move to the system algorithm follow charts. We're gonna zoom. The system will automatically connect to Wi-Fi when power on. Nearby Wi-Fi data is configured in the system. The system will notify the user of the status of level and level data transmission by Wi-Fi. If the screen enter automatic mode, the sensor data will be checked and compared in the real time with the set threshold condition. If it exceeds the set threshold, the control will be turn on the light, pump open the loss K1 and K2. Otherwise, we will continue to wait for the data to compare. Connect the and we move to manual mode algorithm follow chart. The system stay up. Download mode setting from the app. Check the status. Pump K1 and K2. If the K1 pump control processing, the K1 pump control push button test system. If the K1 is fresh, the system to check the current status of the K1 pump. If the pump K1 is on, the system turn on the pump K1, and if the pump K1 is off, the system turn on the pump K1. If the pump K1 is not fresh, the system switch to pump K1 processing, and the K2 is a similar process, and update status and display the information after end of process. The system complete to check and processing step, ending the process, and this is the end point of control up. But the system will still ready to repeat the process and when request from the user. This is the auto mode algorithm follow charts. These are the system start and download auto mode and setting from the app. Read data from sensor. Check the over temperature and check the moisture below threshold. Check the temperature and humidity threshold simulate and end of process, meaning of process. We build the code file for the system in here. Each file in project is designed with a clearly goal and a high modularity. The file such as here I will show you the code. We separate the module to control each function. Here is the main interface. The main function is the central file responsible for the executing the main processing threads of the system, include the logic management function such as the system initialization, execution, and control of the sensor, relay, and the Wi-Fi. This is the function to init the module set at the Wi-Fi sensor, LGD screen, relay, and initial task running and parallel with the free or touch. The running the main function is read the data from sensor, display the temperature and the data on the LCD display and the app. This is the temperature and humidity sensor file to the main function to the manage XT31 sensor temperature and humidity to read data from the sensor via ETUC protocol and ITUC protocol and provide the data to the other module. This is the server communication file. The main function is implement the port and get protocol to exchange the data with the cloud server. The real-time management file. The main function main function is the real-time management of the system through DX3231 module. And this is the relay management file. The main function is control turn on or off the loss in the K1 and the K2. Support the manual mode and automatic mode control module. This is the Wi-Fi. The main function is manage the ESP 32 Wi-Fi connection. And the chapter 5 is the research, experimental research. In this system, we need to repair the laptop, the sensor, the board, the loss, and the less indicator, and especially the IoTVision App with the account activated. Here's the reset of the system. And we're gonna move to the real research.